Hello everyone. Let us discuss examination style exercise 13. This exercise is based on statistics. Here is the first question. The mass of each 200 cupcake was checked by an inspector in a factory. The results are shown by the cumulative frequency curve. Use the cumulative frequency curve to work out the median mass. Second, the interquartile range. And third, the number of cupcake with a mass greater than 116 gram. Okay, so here the cumulative frequency graph is given. Okay, now median mass, you can see mass is given along x-axis and cumulative frequency is given along y-axis. Now when we say median, that means we want to find out the data which is present at the center. Okay, when we arrange data in ascending or descending order. Now I have total 200. Okay, 200 cupcake with their respective masses like 111 or 112. So the cupcake, if I arrange them according to their mass, the cupcake which is at the 100th position is going to be your median. So to find median, what we do, from this 100 we will draw one horizontal line and see where it cut the curve. So it cut graph here. Now from this point we will draw a vertical line. Now when we draw a vertical line, we will see that the vertical line cuts graph at this particular point. So this point, if we see, from 113 to 114, I have 1 2 3 4 and 5 divisions. So each division represents 2 value. So 113.2 4 6 and 8. It is not exactly 8 but slightly less than 8. So if you are saying that 113.8, then also your answer is correct. So your first answer, median mass, it is 113.8. Now mass is given in grams, so 8 grams. Okay, this is your first question, A. B. Second, B is interquartile range. Now interquartile range is the difference of your Q3 and Q1. Now Q3 is your third quartile. So if I divide this whole data in four equal part, each part is considered to be 1/4. So third quartile Q3 will be at the place 3 divided by 4th of your total frequency, which is 200. So in this case it is your 150. So 4 times 50 is 200 and 3 times 50 is 150. So at 150, if I see what value I get here at the bottom, okay, so this is 115.2. So your Q3 is 115.2. Now let us see what is Q1. Q1 is your first quartile. So this is your 50th value. And if I draw horizontal line and then vertical line, I get this value as 112.246. So 112.6. And therefore your interquartile range will be your Q3 minus Q1, which is 115.2 minus 112.6. So the result is 12 minus 6 is 6, 4 minus 2 is 2, and then 1 minus 1 0, 1 minus 1 0. So 2.6. 2.6 is your interquartile range. Now if you want to write, it is in grams, so 2.6 grams. C, the number of cupcake with mass greater than 116 gram. So 116 gram. Now 116 gram. Now look here. This is 116. From here, draw one vertical line and see where it cut the curve. It cut the curve somewhere here. Now from this point, draw one horizontal line and see where it cuts. So if I draw horizontal line, it cut here. Now from 150 to 200, if I see 1, 2, 3, 4, 5, there are total 10 lines. So each line will represent 5, value 5. So 10 line will represent 50. So it is 150. This is 55, then 60, 65, then 70. So 170. So this point is 170. Okay, now there are total 200 cupcake, and the number of cupcake having mass more than 116 gram will be from 170 onwards up to 200. So 200 minus 170, your answer will be 30. So number of cupcake with mass greater than 116 gram is 30. Okay, 30 is your answer. Good question. Now second question. Each student in a class is given a bag of stones for a craft project. The students note the number of stones in their bag. The results are shown in the table where x is greater than or equal to 0, less than 10. Now state the mode. Okay, so mode is the number which repeat maximum number of time. Okay, so each student in a class is given a bag of stone for a craft project. The student note the number of stones in their bag. So in 12 bags there are 19 stones. In 20 bag there are 10 stones, and in X bag there are 21 stones. Okay, so X bag means in each bag, okay, there is 21 stone, and like this I have X bags. State the mode. Okay, so total number of bag is not given. The mean number of sweet, state the mode, find the possible value of the median, and the mean number of sweets is 19.64. Now it is not sweet, it is stone, right? So question itself is little bit confusing. Fine, no problem. Hmm. Because to know mode, I should know the value of x, and from this mean, I can work out the value x. Okay, total number is 12 plus 10 plus x, and the mean sweet is mean stone you say or sweet you say, it is 19.64. So what we do, 19 times 12 plus 20 times 10 plus 21 times x divide by the total is 12 plus 10, 22. 22 plus x is 22 plus x, and this average is equals to 19.64. Okay, so therefore we use calculator. 19 times 12, 19 times 12 plus 20 times 10 is 428. So 428 plus 21x is equal to 19.64 times 22 is 432.08 plus 19.64x. So therefore 21x minus 19.64x will be equal to 432.08 minus 428. 4.08. and therefore the value of x, now 21 minus 19.64, 21 minus 19.64, if I divide, I get value of x as 3. Okay, so value of x is 3. Now as I know the value of x, I can state mode. So 19 is okay, this bag, and where the number of stone is 19, is repeating maximum number of time, it is repeating 12 times, so your mode is 19. Now find the possible value of the median. So when I arrange data in ascending order, there is total 12 plus 10 22, 22 plus 3 25, there are total 25 data. So your 13th data is going to be the median. Now up to 12 we have number of stone 19, then 13th bag will have number of stone as 20, so the possible value of median is going to be 20. Okay, now understand it again. Okay, when I arrange these bags in ascending order, 12 bags I will put where we have 19 stones each bag, then 13th bag will have 20 stone, and from 13 onwards then 10 bags are where we have 20 stones. So 25, if you see what is at the center, okay, so if there are 25 bags, then 13th bag you will find at the center, and 13th bag contains 20 stone, so your median is 20, and the value of x we have already worked out, it is 3. Okay, now B part of the question. The mass m gram of each of 200 buttons is noted and result is shown in the table. Now this time your mass is in range like mass from 5 to 15 gram. Okay, like this we have total 21. Okay, buttons. Now calculate the estimate of the mean mass of the button. So for mean mass of the button, what we assume that there are 21 buttons whose mass is between 5 and 15. So what we assume that mass of each button is equal to their average value. So average of 5 and 15 is 10. So here I will consider their average mass 10. Similarly, from 15 to 17, it is 16. So here x is 16. From 17 to 19, it is 18 average. And from 19 to 25, so 9 plus 5, 14, and 4, 14, 4, 44, 44, 22. So here x value is 22. Okay, what you can do, you can add this 25 and this 19 and then divide by 2. Okay, everywhere you can do the same thing. 17 plus 19 divided by 2 will give you 18. 15 plus 17 divide by 2 will give you 16, and so on. Okay, so now you have frequency, you have x value, so better you can create one more column, okay, which is nothing but your frequency times your x value. So 21 times 10, 21 times 10 is 210. Okay, there is no need to do the calculation. Okay, 1 minute. Okay, so it is not necessary that you make this column, okay, but you have to do this calculation f into x. So 16 times 19, let me do that. 16 times 19 is 304. So 16 times 19 is 304. Then 22 times 18 is 396, and 18 times 22, 18 times 22, here again it is 396. Now for your mean mass, we use formula of f time x divided by summation of x. Now what this numerator mean, that I will add all these product. Okay, so your 210 plus 304 plus 396 plus 396. Okay, so the total we get is 1306. 1306. So your numerator is 1306 and your denominator is sum of these frequencies. So your denominator is 21 plus 19 plus 22 plus 18. Okay, so your denominator is 80. Okay, sometimes it is mentioned in the problem also. The mass m gram of each of 200 button is noted and result is shown in table. Okay, so here there is a big problem. Okay, now if I add these frequencies, it is not 200. So definitely there is something wrong with the problem. There is something wrong with the problem. Here, the total number of buttons which I get is 80 only. So I will do the calculation based on this 80 value. So this 1306 divided by 8080 will give you answer as 16.325. So 16.325 is your mean. Calculate an estimate of the mean mass of the button. Now, on a histogram, the height of the column for 15 to 17 interval is 19. Calculate the height of the other three columns. Okay. Do not draw the histogram. So for drawing histogram, what we do, we first find out what is frequency density. Now, frequency density is nothing but it is your frequency divided by your class width. So 21 divided by from 5 to 15, it is 10. So 21 divided by 10, it will give me 2.1. Then 19, frequency is 19. 19 divided by 2, 19 divided by 2 will give me 9.5. And then 22 divided by, again from 17 to 90 it is 2. So 22 divided by 2 is 11. And then 18 divided by, from 19 to 25 it is 6. So 18 divided by 6 is 3. Okay, so these are frequency densities. Now uh, from 15 to 17 means this interval, height you are showing by 19 centimeter. Okay, so where my frequency density is 9.5, I'm showing it by 19. So what I'm doing, I'm simply multiplying this frequency density by 2, okay, to get these values. So when 2.1 multiplied by 2, I will get 4.2. 11 multiplied by 2 will give me 22, and 3 multiplied by 2 will give me 6. So these are my height. So this is your height h of the histogram. Okay, generally for histogram we consider a frequency density as the height. Okay, but sometime as the values frequency density which we get, they are not convenient. So in that cases, what we do, we multiply these frequency density by some number so that the result is some integer value or some suitable value which we can easily plot. Okay, so again good question which cover a lot of concept. Now let us move to your third and final question. The speed of 150 car passing a 60 kilometer per hour speed limit sign are recorded. So you can see on the x-axis we have speed. Okay, so different cars, they are moving with different speed. Okay, and on the y-axis we have cumulative frequency. Now use the graph to find out median speed. So total 150 car we analyze. So if I want to find out the median, This median will be 150 divided by 2, which is 75. So from 70 to 80, I have 1, 2, 3, 4, 5. So 75 will be somewhere here. From this point, I will draw one horizontal line, which will go like this. And then from this point, I will draw one vertical line. So will your vertical line will go like this, and see, you will get this point. Now this is 60. From 60 to 70 there are 10 lines, so it is 61, 60 to 63, 63. So your median speed is what? It is 63. Now 63 kilometer per hour. Okay, this is your median speed. Now second is interquartile speed. You can do this problem yourself, as already the same kind of problem we have done, okay, a few minutes before. Now for interquartile range, I need Q1 and Q3. So your Q3 will be your 3 divided by 4th value of this 150. So 4 times 3 divided by 4, you can use your calculator if it is allowed. 3 divided by 4 times 150. So your value is 112.5. So 112.5 here, 110, 112, 112.5 will be somewhere here only. So if you draw one horizontal line, the line will go like this. Okay, use your scale, or don't do freehand as I am doing. Okay, so this point is here, it is 70, then 71, 72, 73. Your Q3 is 73. Okay, 3 divided by 4th value, I will say, which is 73, 73 kilometer per hour. Now Q1, so this is your Q3. Q1 will be 1/4. Q1 is 1/4 of this 150. So 1/4 of 150 is your 37.5. So 30, 32, 34, 36, 37.5 will be somewhere here. And from this point, if I draw a vertical line, so it is 51, 52, 53, 54. Okay, Q1 is your 54, and therefore your interquartile range, which is Q3 minus Q1, is equals to 73 minus 54. So 13 minus 4 is 9. 6 minus 5. 6 minus 5 is 1. 19. Interquartile range is 19. Interquartile range is what? 19. The number of car traveling with a speed of more than 60 kilometer per hour. The number of cars traveling with speed more than, so 60 kilometer per hour, you can see here. If I draw one vertical line like this, and then one horizontal line from this point, so here I get 60. So number of car which is traveling with a speed more than 60 kilometer per hour. So from 60 to 150, it is 90. Okay, there are 90 such cars. The number of car traveling with speed more than 60 kilometer per hour is 90. A frequency table shows the speed of the car. Find the value n. Okay, now your total frequency should be equal to 150 if this B part is related to A part. I assume that they are related. So here the total should be equal to 150. So to get the value n, what we do, from 150 we will subtract sum of all this, which is 10 plus 17 plus 42 plus 32 plus 16, 117. So 150 minus 170, result is 33. So 33. Find the value n. So n is 33. Now calculate an estimate of the mean speed. Now to get mean speed, what I will do, first I will find the mean of all these 30, 40, 40, 50. So let me write them as x, and here from 30 to 40 it is 35, from 40 to 50 it is 45, from 50 to 60 it is 55, 60 to 70 it is 65, 70 to 80 it is 75, and 80 to 90 it is 85. Okay, calculate the estimate of the mean speed. Okay, 1 minute. Fine. So what we do, your mean, calculate the estimate of mean. So your mean is summation of your f into x divided by your summation of f. That means your mean is your frequency. When your frequency is 10, the value of x is 35, plus when it is 17, the value of x is 45, plus and so on. The last value is what? 16 times 85. And then you have your denominator as 10 plus 17 plus dot dot dot. Okay, the total frequency is known, which is 150. So you can simply write 150 in the denominator. Therefore, your mean is, let us calculate. So it is 10 times 35 plus 17 times 45 plus the value of n, we figured out it is 33. So 33 times 55 plus 42 times 65 plus 32 times 75 plus 16 times 85. 9420. 9420. So this is 9420 divided by 150. 9420 divided by 150, if I do, I get 62.8. 62.8. So calculate an estimate of the mean speed. Your mean speed is equal to 62.8 kilometer per hour. Now C part, answer this part of the question on the sheet of graph paper. Okay, speed is given and frequency is given. Draw an accurate histogram to show this information. Use 1 centimeter to represent 5 unit on the speed axis and 3 centimeter to represent 1 unit on the frequency density axis. Your bar should be accurate to the nearest millimeter. Okay, so to draw histogram, first I have to find frequency density. So let me write frequency density. Now you assume that I'm writing below this. Okay, I'm writing somewhere here. So frequency density for the first column, it is 27 divided by 27 divided by, now difference of 30 and 50 is what? 20. So 27 divided by 20, 1.35. Similarly for others, it is 33 divided by 10. 33 divided by 10 is 3.3. Then 90 divided by, from 60 to 90 it is 30. So 90 divided by 30 is 3. Okay, these are frequency densities. Now my y-axis represent frequency density and x-axis will represent your speed. So for speed, what is mentioned that 1 centimeter represent 5 unit on the speed axis. So as your speed is starting from 30, what you can do, you can use one kink. Now this kink indicate that okay, from 0, generally we start from 0, but from 0 to 30 nothing. Okay, okay, data is not there. Okay, speed is not there. So why to write like 5, 10, 15, and so on? Better we give one kink which indicate okay that the things which are not present, we cut them short, and from here we can start with 30. Okay, now from 30, after 1 centimeter it is going to be 35. So 35, 40, I assume that by 1 centimeter, here you reach value 50. Okay, now along y-axis, 1 unit represent a frequency density. 3 centimeter represent 1 unit of the frequency density. So for each 3 centimeter it is 1 unit. So from 3 centimeter, like this is 3 centimeter, here I will write 1, then again at 3 centimeter I will write 2, then again at 3 centimeter I will write 3. Okay, so when we are considering 3 centimeters, then in between we will get 30 small lines. Okay, so that will give me a better idea to figure out what is 1.35 value. So 1.35, maybe say here you have 1.3, so 1.35 will be between 1.3 and 1.4, and you will draw one bar like this. Then from 50 to 60, say 60 is here, the frequency density is 3.3, so it will go like this above 3, and then you have one bar like this, and then 3, so exactly at 3, from 60 to 90, so 90 may be somewhere here. Okay, so you will draw one horizontal line like this, and then you drop. uh, so this is your 60 to 90, one bar. Done. Okay, this is your histogram. I hope you understand all the problems clearly. Okay, there is this chapter statistics, okay, is supposed to be very simple chapter. Okay, if you give some time to understand it, you will understand it well. Okay, and the problems are of repetitive nature. Once you understand the concept, you can crack any problem from the statistics topic. Okay, so we will stop here, and I will see you next time with few more interesting problems. Till then, take care. Bye bye.